My name is Wynand Ueckermann. I'm from a company called Afriq Water in South Africa. And on behalf of Afriq Water, I would like to thank IRIO Irrigation for their commitment to the farming community and towards irrigation for giving us this opportunity and for the great venue. This was done especially for this meeting today. Okay, we came all this way to come and tell you how terrible the situation is in Botswana. You know, you dry and it's heat and it's all those things. And I'm seeing jackets and it's raining like crazy. So I don't know if we're at the right place for that matter. But I'm sure that by next week it's going to be warm. It's going to be no rain. And then hopefully what we're gonna share with you today will be applicable to what you're going to be doing there. In the first place, we're going to be discussing dripline irrigation. Because of the dry area that you're living in, dripline irrigation is a obvious choice that you should consider doing when doing irrigation, especially for your vegetable farmers, etc., etc. Then we've got the quick coupling system, which is basically the sprinkler irrigation system. I think we all know the old steel pipes that everybody was carrying around when we were young. So we're going to be discussing that as well. We're going to be discussing irrigation filtration systems. Filtration is something that's so obvious that everybody should know that it's important. And then lastly, we will be discussing a fertilizer fertilizing system. What we've done is we've made a demonstration model, which is this, and we will use that to show you how to apply fertigation, basically anything that you want to add through an irrigation system, your fertilizers, your poisons, and your treatments for your plants. Everything is going to go through there, and that's a system that's doing very well in South Africa because it's very easy. You're using the power of the system to apply the fertilizer, etc. Right. So now we're going to move on to the things that's actually interesting, that's actually nice, and that we all want to hear about, and that's dripline. Everybody wants to use dripline because that's the way to go. Contrary to the rain, that is what we want to do. We want to use a little bit of water, get a crop going, and costing us less money. It's costing us less time. Make it easy to irrigate for us. Okay, so you'll see each one got that sample in your hands there. If you take that out, you will see there's different types of dripline. I'll get to the booklet now. We'll start working through that now. But I just want you to see what you've got there. That is dripline. You will not believe it, but this dripline is actually quite strong. There's three variations there. There's a 0.2. You will feel the one is soft and it's not very hard. That is a 0.2 millimeter wall thickness. The middle one is a 0.6, and the last one, the thick one, that is about a 0.9. So that is wall thickness. Now we're going to start in dripline lingo. We're going to discuss all of these factors. All that I want you to see, what you've got there, is you've got a piece of pipe which is similar to what a manifold would be, a 40 millimeter LDPE pipe. You'll see there's grommets. The grommet is that white rubber there. That grommet is the one that makes sure that you don't have leaks. And then you've got your three different types of fittings. You'll see on the one with the orange ring, that is a ring fitting. The one in the middle is a nut fitting, and the one at the end, a barbed fitting. Now, a barbed fitting is you can see it doesn't have a nut or something to lock it into position because it's so strong. The wall thickness is so thick. You don't need something to keep it there. Remember, you're working at 1 bar. 1 bar is not a lot of pressure. So if you've got that pushed over there and you've got open holes down the line, the water is going to keep on going without pushing that pipe out of the fitting. On these pipes, you will see there's a emitter. Can you all see the emitter? The emitter is embedded inside that pipe. If you look at it, you will see there's on the thinner ones you can see them easily. There we go. Where's that emitter there? You can see, and if you look into that little hole there, you will see there's a color, a blue color, a white color, a gray color. So each color has got a different flow rate. But when we're talking about flow rate, we will get to this now in the booklet as well. When we talk about flow rate is the flow rate of a drip line is measured at 1 bar. When we manufacture drip line, we manufacture and we test the flow rate at 1 bar. That's very important. So if you want to irrigate with drip line, you have to get your water to 1 bar. If you're going to go at 4 bar, you're not going to have 2 liters an hour, or you're not going to have 1 liter an hour. You're going to have, at 4 bar, maybe you're going to have 3 liters an hour. Because the more pressure you're going to give, the more the flow rate is going to go up. And later on, we're going to do calculations. And for that to happen, you need to know how much water do you want to put on the ground. And then you need to be able to control the flow rate of your water. Okay, sorry. Now we're going to get to the reading part again. Okay. Right, irrigation, also known as watering. We all know that. The supply of water to land or crops. Drip irrigation. Now I'm going to read you this because I'm going to forget the whole thing. Drip irrigation, also known as dripper lines, drip tape irrigation, or trickle irrigation. That is an irrigation method or system that delivers water directly to the root zone of a crop in the form of single water droplets. The liters per hour is determined by the emitters on the inside of the drip line walls. This method keeps roots moist but not soaked, all while using less water than other irrigation techniques. This is quite important there. We're delivering the water right at the roots of the plant. We don't have water spraying all over the place. If we've got wheat growing everywhere, you've got to clean the ground. You've got to do a lot of work there. With drip line, you don't need to worry about that because you're putting the water where the roots are. Where you can determine where you want your water, and that's I think in all is that the best advantage of drip line forever. If you ever go to a farm that's using a drip line, well, you know farms that use drip line, you can see that the plants are growing better than any other way. It's even sprinkler irrigation. I mean, I'm very honest with you. Sprinkler irrigation irrigates this whole area, and everything that gets water starts using water. So all that wheat is going to drain the water out, and you're going to lose water out on getting the water to the plants. So we need to get to that point where we have to reduce the use of water. In South Africa, we have a big drive there. In Botswana, you don't have a choice. We've got a choice. There's water there, but well, we think there is, but the water is not the good quality water. So we're all working on trying to reduce the use of water because we don't have much more to use. Okay, so that is a drip irrigation. The first column there. Okay, drip tape. That is also known as disposable drip. We're going to mention drip tape a lot of times during the presentation. So I just want to focus on that one for now. Drip tape is a thin irrigation product. Afriq Drip manufactures a 0.2 and 0.3 millimeter wall thickness drip irrigation that could be classified as drip tape. All drip tape is drip irrigation, but not all drip irrigation is drip tape. So you'll hear people will talk about drip tape regularly. They say, I'm going to put my stuff on the drip tape. But it doesn't mean that it's really tape. If tape is, it starts from 0.13 and it goes up to 2 millimeter, 0.2 millimeter wall thickness. Now we're going to discuss wall thickness now. But so, and especially you guys in Botswana, with all the lime that you've got, it's very seldom that you will be planting with thick, that 0.9, 0.6, that type of drip line. The problem is with the lime, it goes into the nozzle. And no matter what you do, I said earlier that you can't do anything with a filter to take lime out of water. You all know that white build-up in your drip lines. That is a problem that causes you not to be able to use drip line, the thick-walled one. You need to use a thin wall. If you've got some way that the water is clear, then we would recommend, obviously, for the thicker wall thickness, because then you get a better lifetime and it works you out per year cheaper than anything else. But beware of lime. Lime is a bugger. Okay, now the lingo that's there, we're going to discuss how do you determine what type of drip line have you got? Because you're gonna go there and you're gonna say I want drip line, but if you look at drip line, there's a 0.2, a 0.6, and a 0.9, just to name the three favorites there. And in each one of them, you've got a different spacing. So there was 0.2, 0.6, and 0.9 is the wall thickness. We'll discuss that now. Then just to make it difficult, there's about 5 different flow variations. But from the word go, I can tell you, do settle with the 2 liters an hour, maybe a 1 liter if you've got different crops, but 2 liters an hour, 30 centimeter spacing. So you've got 3 factors. You've got the wall thickness, you've got the flow rate of the emitter, and then the spacing of the emitter on the drip line. So if you work out any project, you've got to determine how much water am I using. And then you're going to say, what's the spacing between my drip lines going down the line? What's the spacing on my drip line, the holes? And then you're going to say, what is the flow rate of each one of those? And then you calculate that, and you say, that is how much water I get on the block. Remember that discussion we had earlier? That is where we're going to get to that, yeah. Okay, I just quickly want to read through the paperwork so that I don't miss anything. Okay, wall thickness, shortened to WT, the thickness of the drip line walls in millimeter, literally the wall itself. The outside diameter, the measurement from one side of the pipe to the other on the outside in millimeters. That's normally we use 16 millimeter. We do have a 12 millimeter, but that's more for your crops, short distances. We'll get to that later on. Inside diameter, that's a measurement from one side of the pipe to the other on the inside of the pipe in millimeter. I just want to say, we manufacture the drip line, so we don't have a warehouse and we take it from there and we from Israel or from somewhere and we bring it here and then we put it in the truck and we bring it here. The advantage of making drip line in South Africa and presenting drip line direct to the distributors is that if you've got a special demand, if you say, I've got a demand for 90 centimeter spacing on a 0.2 wall thickness with the 2 liters an hour, and for some reason you say, I rather want 1 liter or 3.8 or whatever the case may be, you can speak to me. And they will be able to order that for you so that we can make it for you as you need it and as you want it. Okay. Okay, liters per hour. The amount of liters emitted by the emitters, those little holes inside the pipe, per hour at 1 bar pressure. We have discussed this before, so that is very important. That is actually when you decide how big a block is going to be and how much water you've got, you're going to need to know that it's at 1 bar. And I once again want to say to you, a swimming pool pump, average 0.75 swimming pool pump gives you about 1.5 bar. And that is ideal for drip line. It works very well. Emitter spacing. Okay, there's very nice carrots here. The distance between 2 emitters repeated across a line, this could be in centimeters or meters. The emitter spacing is something that you decide. You decide how far your crops are apart. A lot of farmers, especially your commercial farmers, they settle on one size. They will say, I'm going to plant a 0.3 meter or 30 centimeter drip line, and I'm going to use a drip line, and then I'm going to plant my crops in a row. So if they plant, if they've got access to water, enough water, they don't bother about going one emitter there and one emitter 60 centimeters for, let's say, for instance, for cabbage 45 or whatever the case may be. They plant a row and they put it 30 centimeters apart, and they've got extra water, and they go on like that. And then they standardize a farm to be just 30 centimeters, and you plant according to your spacing. But you determine what's the spacing eventually, and you can determine that by looking at your plants that you're planting. If you look at carrots, for instance, you don't need to space them big. You can go for a 10 centimeter. We can manufacture from 10 centimeter to 1.2 meters. So if you see, I've got carrots, then you can plant them 10 centimeters apart. But you must remember, each and every emitter takes 2 liters. So normally where you would have 1 meter, 3 emitters in for at 30 centimeters. Now you've got one every 10 centimeters. So you've got 10 at 2 liters, gives you 20 liters an hour. That 1 meter is going to take. The other ones is 30 centimeters, so there's 3 emitters at 2 liters an hour, so that gives you 6 liters an hour. So it makes a big difference in terms of how you design your system and how you're going to decide on which size and which spacing you want to use there. So you must always keep that in mind, the amount of water that you've got available. If you've got only 2,000 liters an hour, then you can only plan a block the size of 2,000 liters. And even if you want to go out and buy Dripline, when you go to IRIO, you don't go there and say, I want 1 hectare, because 1 hectare means actually not much. If you've got Dripline at the 60 centimeter spacing, and the next guy wants 30 centimeter spacing, he's going to want double the amount of meters that you need. You understand? So when you do go to IRIO, you've got to take some basic information, like the spacing between your lines. You've got to say what's the spacing on the drip line, and what is the what is the flow rate of that drip line, of that drippers, because you've got to know that. Number one, to know how much water you need, or how big a block you're going to make with one watering project or watering time. And the other thing that you need is you need to know how much dripline you use. Even if your spacing changes, your fittings, all the fittings that you're using, it's going to change as well. If you change from let's say you would have had 60 centimeter spacing, and then you decide, now I want 30 centimeter. You've got to double all the fittings that's connecting to the manifold there. Okay. So that's very important. We have to have a lot of information before we can really help you. Okay, so I'm just going to carry on with the emitter, a small plastic device used to control the flow rate of liters per hour of water from the system to the emitter hole. Welded to the inner walls of the dripline pipe during manufacturing. The design of the emitter is unique between each different variety of liters per hour, engineered to obstruct and control the movement of water to deliver a precise, accurate flow rate and to ensure that the farmer has a complete control of their irrigation system. So that's a lot to say. But basically what it comes down to is each emitter, and you look at the photo, I mean, you can look on the pipeline there that you've got there, you can see, especially on the thin one. I just want to use yours here. Especially if you look at the thin one, you can see that is your emitter. And each emitter has got a different labyrinth to stop the water. So you're coming in with water at 1 bar, and that's how it determines the flow rate. The emitter is designed with the labyrinth that's in there. It's designed at 1 bar to give you, for instance, 2 liters an hour. So each flow rate has got a different emitter. There's 1 liter, 1.6, 1.3, whatever the case may be. Each of them differs from the next one, and that one will give you just that flow rate that you need. Okay. Right, here we've got the benefits of drip. We've discussed some of them already, but I think it's useful to go through a lot of them. Okay, Dripline offers a steady, consistent application of water to help plants grow fast and plentiful. That is what we all want. We all want that to happen. Frequent, smaller doses of water delivered to the root zone, controlled entirely by the farmer, promote higher yields and more controlled quality. If you look at this picture that's next to that, you'll see there's rings. So if that emitter puts down one drop, that drop grows in a circle. So eventually, and that's what I said about some of the farmers earlier, they will let that whole ridge get wet from one side right through to the other side, and then they plant, and they don't worry about spacing in between the plants, etc., etc. But that is ideal. What you want to see in a drip line, if you look at it on the ground, that is what you want. Okay, right. So the benefits are lower water consumption. Drip irrigation delivers water directly to the root zone of your plant. This limits water waste and evaporation. Now, we've discussed that. Drip irrigation delivers water directly to the root, and you don't have wasted water going to the weeds. All types of crops and land are suitable for this method of irrigation, from field crops such as maize, soya, beans, sugarcane, to vegetables and tree crops. This type of irrigation you can use anywhere. We even use them for our pecan nuts, where we do a line going through, and then around the line, the tree, we make a round circle with the emitters in, and those emitters put the water down right next to the tree. So for your trees, for everything, you can basically get away with the drip line. High crop yields and quality. Because the moisture levels are kept at an optimal range, plant productivity and quality improve. A thing that happens a lot, and that's a thing that we've seen in all farming communities, is overwatering. The only thing that I think that's worse than overwatering is no watering. Overwatering is as bad for your plants as it is to dry them out. I promise you, if that plant can't have oxygen to use to grow, then that plant is drowning. And while it's drowning, it's not growing. It can't grow while it's drowning. So one of the things that we get, especially with flood irrigation, for instance, people put the trench down and they put water in and they flood this, and it takes 2-3 days to dry up to a level where it can start absorbing oxygen again. So drip irrigation is very good at that. And I always tell people, and they say, but I don't know how much water to use. I just showed them earlier there. I took that sand here. I mean, this sand is dry. And if you go there and you scratch with your finger, you can see it's wet. It's not wet, it's moist. There's no water dripping out of that. But that's what you want. You want your plants to be moist. That's why a farmer, his nails should also always be full of ground, but soil at the bottom. That's where a farmer's fingers should be. He should be out there scratching in the ground. If he doesn't do that, he's never going to know what's going to happen. And that's why a farmer needs to be in his farm and checking that. Okay. Sorry? Yeah, yeah, it has to be. Okay. Drip irrigation prevents diseases by minimizing water contact with the leaves, stems, and fruit of plants. Now, a lot of plants don't want water on them. For instance, if you take a lettuce, they don't like water on the leaves. Tomatoes, there's a lot of plants that don't really want to have water on the leaves, on the stems, and all that type of stuff. So for that, the drip irrigation makes sure that the water that is put there doesn't splash, doesn't fall on the leaves. So that's also very good for that. Easy installation and dismantling. If you look at the dripline system and you think, wow, this is difficult. Oh, you've got to do up and down. You've got to roll it off. You've got to take it there, and then you come back and you've got to put it on a manifold and you put it on a valve, and it's a lot of work. It's once you work once, and I tell you what, you from there on, from the rest of the crop, well, for the time that the plant is growing, you're going to go there, you're going to open the valve. 15 minutes later, you come back, you close that valve, and that's it. You watered the block. There's nothing easier than dripline. Irrigates uniformly most topography and soil types with precise water distribution. There is the topography. There is a problem there if you've got land that's sloping, a lot of sloping. Because if you're going to start watering, if you're going to be starting watering and your land goes slopes down, then obviously, like remember earlier when we said that the pressure, if your pressure increases, then your flow rate increases. So now what's happening? If you've got a slope like this, you've got to put water in there, but here's 1 bar. By the time it reaches here, is 1.5 bar. So these plants at the top is going to get water 2 liters an hour or 1 liter an hour. The one at the bottom is going to get more flow because the pressure has increased because of that slope that's there. So if you do design a system and you do have a sloping soil field, you have to, if the slope is like this, you put your drip lines like this. You always try to follow the levelest area with your drip line. So you don't go against the grain and go down. You would rather take 3 or 4 lines at the top and make them 1 block, and then make 4 lines again, so that the difference between the top line and the bottom line is not that big. So that's always, you always keep cross from the fall of the field. And then another option is you can go with the pressure compensated, but that's very, very expensive. And yeah, but that is a very expensive drip line. The guys with the in Nelspruit, and but you don't really have fruit trees and that in Botswana, no? No, I don't know. Yeah, the fruit tree guys, they use pressure compensated, or they've got that other system. All of you must have seen a button dripper, that little blue one. Push a hole in the pipe and you put the button dripper in there. But that's another option there. That's also pressure compensated. Energy savings. Drip irrigation works on low pressure, the swimming pool pump, and lines lines can run with gravity if the topography allows. We've done systems where we don't even do pumps. We use just gravity. And if you take, for instance, if your lines are not too long, and you just want to water, let's say if you make your lines this length, and you want to use that water, you can take a tank at 3 or 4 meters and take the water from there, and that will water that lines sufficiently. The problem if you don't have pressure behind your system is you can't go long distances. So because of the friction loss in your pipe, that pipe is only 16 millimeter wide, thick, wide. The water, if you've got to put the tank here at 3 meters and you want to water to the end of this shed, you're going to have a problem at the end of the shed. There's going to be no water coming out. The water is all going to come out here at the front of the project. So just so that you know, to keep that in mind as well. Okay. Reducing energy use provides great financial benefits to users. I mean, that we all know. We know electricity is scarce and there is not a lot of that to go by. Efficient use of fertilizer, fungicide, and insecticide with no seeping. So that's another thing. If you look at fungicide, fertilizers, all of that type of stuff, that's expensive. I mean, that's really expensive. If you take a sprinkler and you irrigate this area, you're putting fertilizer on the weeds, you're giving them all that they need to flourish, and your crops are going to be standing. With this, you're giving water and fertilizer to where you need it, so that the rest doesn't get it. Reduced wheat growth. There's a wheat. I should have just waited. Less dependency on weather conditions leads to greater stability and lower risk. So, yeah, well, that's basically, you don't need to wait for the rain. You can just open the valve. Efficient watering via systems like drip irrigation can help ensure sufficient supply of food for all of us in the future, and a more stable crop and higher yield for farmers. Now, that is very true. If we start going towards dripline, and worldwide, there's a big move towards dripline. I mean, there's countries that's got even less water than Botswana, and they all go for that. And Namibia, for instance, Namibia is getting on the bandwagon now. They're going big in terms of dripline. I think my my opinion is that going forward, dripline is going to be the method of choice of irrigating. Water is scarce, generating water is expensive. Whether you use whatever, it costing you a lot of money. So the way forward in terms of irrigation is going to be dripline. I mean, worldwide, the tendencies there, we're looking at a lot of the countries outside South Africa, and especially in Africa. This is a new thing for us. 5 years ago, 7 years ago, when I started the business, no, 8 years ago, when we started the business, I said, Africa is not ready for drip line yet. 5 years ago, I changed my mind. I said, Africa is now getting ready for drip line. And I think in the next 10 years, drip line is going to be the way to go forward from here. Okay. Right. Okay, we quickly going to go through all the different types of dripline. Okay, types of dripline. Flow and spacing are dependent on what your plants need, and that can be customized at our factory, available per order from IRIO Irrigation. When choosing wall thickness, farmers often have to choose based on finances. More durable dripline is more expensive than drip tape, for example. Now, that's, I think we've just discussed this kind of finished, we've finished going through this. The bigger dripline is more expensive. The price of the dripline is determined by the amount of material that goes in there. If you've got a 0.9 wall thickness and you've got a 0.2 wall thickness, obviously per meter, the weight of that line is going to change. The emitter stays the same, everything stays the same, nothing changes. It's just the price of the material. And the material the dripline is made of is extremely expensive. We do get it in South Africa. We've got a recipe for ourselves. Each and every supplier has got their own recipe. So because our material doesn't come from Israel and put it down on the floor and I just distribute it, we manufacture for African standards. If you look at the sun in Botswana, it's bloody warm. And even if you look at the sun in South Africa, it's not that warm there. But we cater for African climate because we take it out up to Tanzania, the furthest, no, Kenya. Kenya is the furthest that we go with our dripline. And we add extra UV because we know without the UV, it's not going to last. A dripline from Israel, which is kind of warm, or Turkey, or wherever the case may be, that dripline is not as efficient in South Africa as I hope ours is. Okay. Okay, so the first one we start off with is it's called the light. You'll see there's categories on the right-hand side. There's a 0.2 millimeter wall thickness, a half-year dripline that comes standard in rolls of 2,000 meters. We recommend this dripline to anyone who has lime in their water. Once again, lime. Lime will clog any emitter, even if the pipe is strong enough to last for years to come. So we've got the first light was a 0.2, then we've got a 0.3 light, a 1 year dripline that comes standards in rolls of 1,250 meters. This dripline is typically used by tunnel or roadhouse farmers. 0.4, that's now the medium that's starting there. A 3 year dripline that comes standard in rolls of 1,000 meters. This dripline is ideal for farmers who want a medium irrigation solution. Usually farmers consider the operative and economic situation to decide what will be better for their crops and needs. 0.6, another medium, a 4 year dripline that comes standard in rolls of 700 meters. This dripline contains UV, giving it more UV, should be, giving it a longer life expectancy. Usually farmers use the 0.6 millimeter wall thickness as a long-term solution. 0.9, that's a heavy. That's a 5-year drip line that comes standard in rolls of 500 meters. This drip line is our second most durable drip line, infused with extra UV for durability and longevity, even in full sun. And then there is a 1 millimeter wall thickness, heavy, a 5 or more year drip line that comes standard in rolls of 400 meters. This drip line is our most durable drip line, infused with the most UV for durability and longevity, even in the full sun. The pipe is unyielding and very tough. So there's a couple of things to consider. If you go for a thick wall, if you feel that, you can feel it's kind of hard. The thick one, you can feel it's getting hard. Now, if you go to a 1 millimeter, I mean, that thing is like, you've basically got to heat it up and then put it over the barb fitting, and then, then use it. So they do differ. The thinner one is very easy to work with. The medium one is also easy to work with, but the 0.9 does get difficult in times. And but yeah, it works well. Right, as you saw on that sample that we gave you, you'll see there's 3 different types. There's the light, the ones that we discussed now, the 0.1, 0.2, and 0.3. They will work with a ring, that orange ring. The medium one, the 0.4 and the 0.6, will work with a nut, that one in the middle, and then the barbed fittings. This is now all about fittings. The barbed fittings will work with your thicker, big, strong, hard to use drip line. Okay. And if that hard one it's difficult to work with, but once you've got it a little bit over there, it's as difficult to get it off as well. So, but that is a good thing, because you don't want that to jump out when it gets to pressure. If you're working with high pressure and you can't control the pressure, then obviously the better choice is a thicker drip line. When we manufactured the 0.2 millimeter drip line, we do a burst test. So we don't do it over a period of time. We take water at the pressure and we put it on the drip line, and we check where it bursts. It can go up to 4 bar. So 4 bar is actually very high for drip line not to burst, and that's on the 0.2. Now imagine the big ones, the thick ones, they go 6, 7 bar. And we don't even bother with them. They can't stand that temperature, that pressure for a long time, but that's where they burst from starting to test them. So if you look at that page, number 5, I think it is. Number 5, with all the types of drip line fittings. Now, drip fittings, this on the left-hand side, I'm going to start with one at a time. There you will see on the top left side, you see there's an off-take connector. That's the same as you've got in your sample there. On the right-hand side of that, you will see there's a valve. There's different options. So you can do a lot of things with all of this. So you can have a valve that can instead of a big valve to control a complete block, you can put each line on its own valve. So there you've got a little valve, same as this. Well, the concept is the same. So it's going to be like this, and that you can start off and say, right, okay, I want my line to start with a valve. I want to be able to open and close it, and then that is a solution for you. There's 5 different things there. Just below that valve on the right hand side, you'll see there's a fitting that's got 2 orange rings at the side. Now, working with drip line, you do get the guy that's going to come with a pick and he's going to cut the drip line, and you get a thorn going through, and you've got to join that drip line. So that's a fitting that you will use there. That's a drip joiner. So it uses the same principle, 2 rings on two rings on both sides. You put your pipe over from both sides, and then you've joined your pipe there. And then at the bottom there, you will see there's an end cap. So you will begin your system that you've got there. You will cut a hole in the pipe, in the big pipe, which is a 40 millimeter pipe. You'll cut the hole there. You put your fitting inside the hole. So what you do is you take the pipe, and then there's a fitting, a cutter. So this cuts the holes in that pipe. So you don't need to run around with a drill or air drill or something like that. So you don't need to run around with stuff trying to drill the holes. And if you do use a drill and you don't control it, you go right through to the other side, and then you lose your piece of pipe. So on your manifold, we recommend that you use a drill similar to this. You push it in, you turn it. It's sharp like hell. It will cut you. So just beware of that. And then you make the hole, and then you put the grommet. That shiny see-through one. That's a grommet, the gasket. So then you push that into the. Let me do one here. Wait. They're not easy to get out though. So I'm gonna just show you. This would be your manifold, and please don't go smaller than a 40 millimeter. The radius on the 40 millimeter is of such that this works there. The gasket works there, so that you're not going to have leaks. You go to 25, 32, or anything like that. The radius is too small. This gasket can't stop the flow of the water there. So you will take that pipe. Let me do the whole thing. Okay, so this is actually very easy. You just take it like that, pull it out, and then it's stuck here, but it's kind of difficult to take out. Okay, so that's an easy way. There's other ways, but this is the easy way. Then you take this grommet and you push it in here. You'll see there it goes in there. And then she said we should use sunlight liquid, but really sorry. This is a farmer's day. It's not a you push that in there, and then that is sealed. That's closed. There's no problem there. Farmers don't worry about nonsense. Okay, and then you take your tape like that. You just open it a little bit. You'll pull that ring back towards the wall there, and then you just slide it over, and you pull that back, and then you will see your plastic, your pipe sticks out behind the fitting there, and then you can try to take it out. You're not going to take it out. It's good. It's at the angle, so this is there. The same principle applies to the nut, but what the nut does is it's got a. Yeah, I'm not going to take it out. Okay, but what this does, it's the same thing. The grommet goes in the same way, and then what you do is you'll see you push it you push it in. You turn it towards the pipe. You'll push it in, and then there's a lip there. So when you push this over there, and then turn your nut back, then that is where normally people get confused and they want to turn it tighter like we normally do, and then they get stuck. So this is also quite there. This is a barbed one. I didn't push this in very far, but as you can see, when it gets there, it gets tight. But this one, you struggle a little bit to get it in, and once it's there and it cools down there, it's tight. So one bar is not going to push this out, but the principle of your barbed fitting and your grommet stays the same. The size of your pipe stays the same. Please, no smaller than 40 millimeter. It's not going to work as it should. Okay, right. And even if you look at the inside, you can see at the inside you can see the grommet, the fitting of the pipe, everything as you can look at it there. Okay. So that's the fittings there, the types of fittings. Now, if we go back to the dripline fittings, we can have a look there. You will see the offtake. It's a nut like that one in the middle. Left on the top, it's a nut, and then there's a valve next to it as well. And right below it is a connector, and on the left of that there's another valve. So different options with the valves. And then there's a thing, it's called glasses, because it's like glasses, like your glasses. So what it does is on this one, you will push that glasses over this, and then bend it over, and then pull it back. and then it will look this like this. Okay, so that's Dripline up to now. So now the next part of the Dripline that we're going to be doing is we're going to be talking about how to design a system and how to determine how much pipe you're going to need and all that type of stuff. What I said earlier is that we're a factory in South Africa, so we manufacture according to order. If you say if you say that you want a hole every 60 centimeters, then you get it every 60 centimeters. If you say you've got all a range of choices. You can decide what is a wall thickness that you want. You can decide what's the flow rate that emitter must have. And you can decide what's the spacing on the emitter. Okay. You'll see that the pipe works out that, for instance, on the 0.9, the thicker wall thickness, there's only 500 meters on a roll. But on the 0.2, there's 2,000 meters. But obviously, that's because of the amount of material. The 0.9 has got a lot of material. If you weigh each roll, they will be roughly in the region of 18 to 20 kilograms. We don't make a roll heavier than 20 kilograms, because doing this the whole day and rolling out Dripline and all that, they get heavy. And when you see a roll like this, I just want to show you a roll here. You will see in the middle there's a black cap. No, you're not going to see it. Okay, but in any case, here is a hole through the middle there. You put the pipe through, and then on this side it tells you unroll in this direction. So then you'll start rolling this Dripline like this. Two guys will have it on a pole or a stick or whatever the case may be, and one guy walks down the line with it. When he gets to the end of it, you cut your line and you take the next one. You do that until you've done all of that. But all those rolls is plus minus 18 to 20 kilograms. And that's a comfortable weight for two guys to carry, because they're going to be walking with that, or the one guy is going to walk up and down with the end of the pipe. So it doesn't matter what way you do it. What is actually important with Dripline on the rolling out side of it, you must make sure that the emitter, the hole that you see there, that hole must be on top. If you put your Dripline upside down, you can get ants going in or whatever the nonsense is. But it's preferably you put it with a hole on the top. You don't have a lot of wind here, although I see there's been some damage because of wind. But if you switch your line off, your pump off, there can be water inside the pipe. It's fine. It's okay. And then that water that's there can actually anchor the Dripline down, so that it can't fly away when there's big wind coming out. Okay, so once you've decided what you want to do, and what you're going to plant, and how much water you've got, all that, you can work out how much you can how much you're going to need to do that. It's actually, there's a very, very, very easy calculation. There's a few factors. One, you have the length of your field. Remember that we're not going to go against the slope. We go as level as possible, always. So, and then we know what we've got. On each row, there's a sticker here. That sticker tells you what's the maximum length that this drip line can go. So if it says 83 meters, go 75, don't go 85. All the information is on there. So it tells you this is a maximum length from here to there. But that is if you've got 1 bar pressure. If you have, we spoke of gravity earlier. If you have gravity feed 4 meters, you can't go 100 meters. You don't have enough pressure to get to the end there. So keep that in mind always. And all the information you need is on there. You can work on all the information that is there. So, okay, getting back to the design system. Number one, you must know what's the length that you're going to go, your beds. Whether it be 20 beds or 10 beds, whatever the case may be. You need to know how long is that line going to be. In one bed, you can have 2, 3, 4 lines. So if you know I've got one bed and there's 2 lines inside there, then and they're 30 meters long, then I know it's 30 meters plus 30 meters is 60 meters for one bed. Now we're going to get back to the point from where all the calculations begin. There's either one or two ways. Either you begin with your flow rate of your water, because the limiting factor is how much water have you got. If you've got 1,000 liters, you can't do this whole area in one go. You're not going to get there. If you've got 10,000 liters, you can do 20, I don't know, 3 or 4 of these areas. So the first thing that you've got to determine is how much water have I got? And literally, if you've got 1,000 liters, work on 750. Once again, always play it safe. So then you take the amount of water that you've got. Let's say, for instance, you've got 10,000 liters an hour that's available. And let's say you've got 10,000 liters available and you're using the 2 liters an hour drip line. So in other words, you can accommodate 5,000 emitters. Those emitters that's going around. You can accommodate 5,000 of those emitters. If your spacing is 50 centimeters, it means you can accommodate 1,000 meters. Yeah, my calculation is not all that good. So then you know I can accommodate 1,000 meters. And now you stand back and say, I've got 1,000 meters. I want 30 meters, 30 meter lines, and there's 2 lines in a bed. So that means that 60 meters in one bed. I can accommodate 1,000 liters. That's all. So then 1,000 divided by 60, I don't have a calculator with me, but let's say, just for the sake of the argument, let's say that leaves you with 14 beds. So you can do 14 beds. You can't do more. You can do less, you can't do more. And coming back to the swimming pool pumps that we discussed before, for 0.75, you're gonna get a pump that's gonna give you 18,000 liters of water an hour at 1.5 bar. The advantage there is with that pump, if you've got a reservoir like the outside and you're working with that pump, then you know this pump's capacity is so much. If you're working from a borehole, you know the water coming out is so much. You cannot change that. So the factors that you need to know is you need to know how many meters of pipe can I accommodate with my pump. How much water is my pump delivering at 1 bar? How much water is my borehole delivering? So the calculations has got to be right always. So if you come to a point where you say, I can do this block, then we've got to decide how are we going to, let's say, what would you say, 14 beds. So we can do 14 beds, they're 30 meters long, and there's two lines in each bed. So then we go and we say, okay, right, now we've got to do the design. Here's all the lines, here's all the beds, two, and here's where we're going to start. Our water is coming from this side. Now, I just want to give you a typical example of how it works. To me, it's got some very nice designs down at the bottom there, but now with the rain, we won't be able to go there. So what you will do is your water from your supply will come in. You will have a filter there, preferably. You don't have to. If you've got a filter and it's doing sufficient cleaning of the water, that's fine. If you come into a block, normally for me, I put a filter each block. It just makes it double sure that it stays clean. You'll come in with a filter, and then you'll get to a T-junction, and you will tee off to both sides. You must always try to work to both sides. If you go into a block, like this, and you come in on this corner here, and you've got your manifold going down here and all the lines down there, but your main supply is here. These pipes are going to get more water than those pipes. You always try to find and to design your system in such a way that you're always in the middle. You always come in so that what we're trying to do is to get the water as evenly distributed in this block as we can. Okay. Any questions here? Are we clear there? Okay. So you will all be able to know and to work out how much you want, how many meters you need. It's very, very, very straightforward. You can't create water where there's no water. You've got it. You can only work with what's available, and that comes down to we spoke about filters earlier. If you think of the filters, we said that the filter is designed according to the flow of the water. Exactly the same applies here. If you're going to put a block here, maybe you'll have a filter bank at the pump. That filter bank will have a filter for 40,000 liters of water, because your pump is giving 40,000 there, but you're only using 10,000 here. Then this block here, you buy a filter for this block. So that might be a 40 millimeter filter or 50 millimeter filter or whatever the case may be. Okay. Sure. So that was about it in terms of, I think, Dripline. Is there anything more to ask about Dripline? Sorry.
I just need a clarification here on the meters.
On the
meters.
Okay, yeah.
You say the meters will differ. Like, for example, this one. This one is, you can just see it with another color. This one is
Okay, do you mean like this?
like this.
Yeah.
You once said with this one, it produce the water which comes from this one may differ. So does it mean if you want more water or whatever, something like this one cannot produce the same water?
No. Each one has got its own flow rate. So that's why that's one of the things that you've got a choice. There's very few things in life that you've got a choice, but here you've got a choice. You can decide how much water do I want. This one is 2 liters, and I think this one is 1.6, 2 liters, 1.3 liters. Because now, if say for instance you've got this block, and yeah, see you just need 5 lines extra, and you know I can't put another block there just for the 5 lines. Then you go, there and you say to IRIO, and you say, I don't have enough water on my block for 2 liters, but I can do a 1.6. You see, then you calculate. So you can work out exactly up to the point where you know I've got 10,000 liters, and you know I use 10,000 liters on this block. Just by changing that. So this is basically what it's all about on the drippers.
When I want more water, I do away with this one. I go for this one.
Yeah, you can't. You see, this one here is welded in. It's literally welded in there. So you can't take this one out and put in another one. If you decided I want this one for that crop, then that's what you get. You can't take it out and change it or nothing. What you can do is, if you the way, say for instance you've got this one, nah? And you wanted this one actually. So now you say, hey, this one is too fast. what you do is you change your time. Remember, what's very important is if you're gonna water 15 minutes with this blue one, and that's 2 liters an hour, and this one is 1.3, and you see, hey, this one is very fast, it's coming too much water, then you decrease your time. You understand what I mean? You're still getting the water there, you're getting more water, but you reduce your time. And yeah, I don't want to complicate it now. Okay, but there is ways of seeing how much water you're dispensing at an hour in terms of rain. Yes, as if you could compare it to rain, you would be able to see that. For you, and I go back to what I said earlier. A farmer's finger must be dirty. There must be soil under his nails. He must scratch in that soil, and he must see if my plant is wet. I stop for watering. You don't water till the plants are struggling, drowning. You water until the plants have got water. This irrigation, we're all used to that sprinkler irrigation. You put it on this morning, tonight you go switch it off. Doesn't work like that. This, you're putting water where you need it. You don't have to give that much water. So you're going to go out there and you're going to open this valve and you're going to water for 15 minutes and you're done. Then this afternoon you open the valve, 15 minutes, you're done. Tonight, if you want to, 15 minutes and you're done. You don't, it's not like conventional irrigation where you just let it run. You are putting the water where you want it. You don't need to water the pavements and the paving and the grass and everything like that. You just need to water what you need to water. Okay. And that's what makes it so wonderful. This is wonderful stuff. It's easy to work with. And if you see you don't have enough water on your plant, you increase the time. So everything has got a solution. Okay. Any more questions now? And please do ask. Please. Maybe I'm forgetting something and we need to take that on. Okay.
Water calculation, very important. That's one. A lot of the times what we get is, say the spacing is 30 centimeters, and then somebody calculates the amount of water that they have. And no matter butternut at 60 centimeters, what we must not forget is that hole on a 30 centimeter spacing drip, whether there's butternut there or not, so you have to account for that. So it's best to instead of like a 30 centimeter, get the right drip because you're going to lose water. When I talk about your plant population, you are using 30 instead of 60 centimeter drip. How about I kunyetsa? Ba bangwe ba re ba kunya ba re ba oketsa diphara. Wa bo dira spray shoe. Go godimo. Ba tlo go dripa ya. Because each hole in a little spinach, which controls the flow. Le gore metsi a tsamaya. But other people mo tsa ba nna ne ke a kunya go dira diphara. Then metsi a go godimo.
Okay.
You don't have a working formula for the water which you want to use. The formula for calculating.
I can give it to you. Yeah. So basically, it's a very easy calculation to do, but please, it's not that easy. So what you do is you take your lines. You say this line and this line. What's the distance in between that two lines? Huh? And you take that in meters. So say this space is 60 centimeters. So that's 0.6 meters. And the spacing between one emitter and the next emitter is 0.3. Calculator. Okay, let's do one. I'm going to do one calculation, and then we're gonna work from there. Okay, so my spacing between the lines is 0.6 meters. Times multiply the spacing between my emitters, 0.3. That gives me an answer of 0.18. Now what I do with this answer, I take this 0.18 and divide it into my liters per hour. Let's say I have got 2 liters an hour in my emitters. I'm going to do it again. I'm going to do it again after this one. In a 2 liters an hour on the emitter. So I'm going to take 2 divided by 0.18. 0.18. And that gives me 11 millimeters of water like rain. You understand? So I first of all I take my I want to do this again. I take the spacing between my drip lines in meters. And I say there's 60 centimeters, 40 centimeters, 100 centimeters, doesn't matter. I take that measurement, I multiply it with my distance between my emitters. No? I take the sum of that and I divide it into the flow rate. Okay. That is a calculation you use on dripline. That's a calculation you use on sprinklers. That's something that in a farmer's head, that's a one calculation you need to have. That's a very important calculation. Okay. Thank you. Thanks a lot.